I'm Anil Kumar, and in this video we'll try to understand why trigonometric functions have many solutions. C1 is a communication question. It says find all possible values of angle theta rounded to one decimal place for sine theta equals to 0.4321. Now we can easily answer this question, but let us understand the concept behind it. So let us consider our coordinate plane. Now when we are talking about the angle theta and sine theta in particular, then what we have is that if we consider a unit circle, let's say radius is 1 unit, origin is the center of the circle, and if we draw a circle like this, then every point on this circle can be thought of having a value which will be x and y, right? So any point on the circle will have a coordinate value of x and y. Now if we say that the radius is 1, that means if we say that the radius is 1, that is what we mean by the unit circle. In that case, y coordinate value, which is vertical distance, represents sine theta, right? So in general, if we have a unit circle, consider a unit circle. That means radius equals to 1. In that case, sine of theta, theta is the angle which the arm of the circle which is moving makes with the x-axis, and it's moving along in counterclockwise direction. So that is the counterclockwise direction. That in this direction theta is considered to be positive. Sine theta, will be y over radius. Now since the radius is 1, we can write y over radius. Since the radius is 1, it is equals to y. So the value y actually represents sine theta, right? Now let me extend this to time axis. Let us say we are moving along about the point O on a unit circle. Then now we understand the y value represents sine theta. So if we start with position on the x-axis, at that time the value of sine theta is 0. So that is how you get 0. So as we move towards 90 degrees, the value of y changes from 0 to 1 if my radius is 1, right? So sine theta changes from 0 to 1. So that is kind of change. And after 90 degrees, it reduces, and it reduces to 0 at 180 degrees. So then it drops down to 180 to 0 at 180 degrees, correct? So that is the positive half of the circle. As we move down, let me use another ink in this case, then the value increases from 0, but it is on the negative side. So it's negative 1 here, do you see that? So it increases to the negative side to 1, right? And then after this it reduces back to 0. Once it comes back to 0, we have covered how much? We have covered 360 degrees, right? This was 270 degrees and this is 360 degrees, correct? So this one cycle is your sine theta, where theta is changing from 0 onwards, and this point we found was 90 degrees, this is 180 degrees, this is 270 degrees, and this one is 360 degrees. Now if we move again, we repeat all these values. So the second cycle starts. So let me draw the second cycle. This is the positive one, and then as it crosses 180, it goes back like this, okay? So this time the angle, you can say, increases, and it becomes 360 plus the previous angles. So at the end of the cycle, it will be 720 degrees. So as you can see, sine theta increases, but I mean the theta increases, but the sine value changes between positive 1 and negative 1, correct? So that is the limit for our sine function, positive 1 and negative 1. Now let's get back to the question. It says sine theta equals to 0.4321. So it's kind of slightly less than half, right? So 1 is here, half let us say is there. So 4 point, let's draw a line here. So when we say sine theta equals to 0.4321, we are looking for this point. So at this point, the value of sine theta is 0.4321, and the question is find possible values of theta. So the possible values of theta are these, right? So 1, 2. Likewise, we get so many values of theta. The cycle moves on and on, right? Now as it moves, we get more points, which are 360 degrees away, right? You can see distance between these two in terms of theta, or change in theta between these 2 points will be 360. Trigonometric functions are periodic, and sine theta has a period of 360 degrees. So what we really find is that if we can get one value of theta, the others we can get by adding 360 or also by subtracting 360. That's the whole idea, and that is the reason why we have many solutions to our trigonometric functions. Now let us use calculator to find solution of this equation, which is sine theta equals to 0.4321. Now to find the value of theta, we'll find sine inverse. So shift sine theta, that gives us sine inverse. 0.4321 equals to, gives a value of 25.60. So to find theta from here, what we found was, we know that sine theta is equals to 0.4321. Then theta should be equal to sine inverse of 0.4321. Now to find this value of theta, we can always use calculator and find an answer. So we get the answer as 25.6. To one decimal place, it is 25.6 degrees. But you can clearly see from your example that even in 0 to 360 degrees, we are looking for two solutions, not just one. So we got the first one, which you can see is here, 25.6 degrees. How do we get the next one? Well, from our circle, we can say if this point is on this side for the same theta, then the value should repeat. So that theta, how much is this value? This value is 180 less than the angle which we found, right? So the other value of theta should be equal to 180 minus 25.6. As you know, sine is positive in quadrant 1, 0 to 90 degrees is quadrant 1, and then from 90 to 180 is quadrant 2. So if you have sine as a positive value, you are looking for two possible solutions, one in quadrant 1, the other one is quadrant 2. That means one between 0 and 90, the other between 90 and 180. So what is the other value? So the other value of theta should be, we can write, or theta equals to 180 degrees minus 25.6 degrees. So that gives you the other value, at which it is same as 0.4321. So let's find this out. 180 minus 25.6, that gives you 154.4 degrees. So we get the two values which we are talking about. Now you can see after 360 it repeats, and after every 360 it repeats, and therefore we have more solutions than just two given here. So in general we can write theta equals to 25.6 degrees plus or minus, since it could go on the other side also, 360 degrees times k, where k belongs to integer number, k belongs to integers. In that case we don't write minus, so we can say k belongs to integers. Okay, or theta is equal to 154.4 degrees plus or minus 360 degrees k, okay, where, as I said, k belongs to integers, right? K could be plus minus 1, plus minus 2, and so on, right? So these are all the possible values which theta can have for sine theta to be equal to 0.4321. So in this video, what you understand is, since the trigonometric function is periodic, the value of the angle repeats, and we can find the new values by adding or subtracting multiples of 360 degrees. Now, first thing is, we should find the possible two values within 0 to 360 degrees, and then we can add multiples and get rest of the values. So that is how we are going to solve most of the trigonometric equations like this. So for sine theta, if a value is given, theta will be sine inverse of that value, and that value repeats after every 360 degrees. I hope you appreciate it. Thank you.